model. Right here I'm going to show I think it's about a 7-minute video, which I think you're going to find very interesting. One thing to point out is that the Michelson Morley experiment was rotating on a horizontal axis, right? This interferometer moving in this direction, because it was assumed, this ether wind concept was assumed to be relative to that plane of motion on the Earth. And what we're going to see is something that the person who did this particular experiment emailed me this, I don't know, maybe 10 years ago or whatever, and it just blew my mind because I knew what the implications would be. So anyway, let's go ahead and play that real quick.
Hello, my name is Martin Grusenig. I'm from Germany, and I would like to introduce 2 experiments to you, which I have conducted with a modified Michelson interferometer on August 14, 2009. I'm using a simply constructed interferometer designed after Albert Abraham Michelson for the following 2 experiments. As a light source for the interferometer, I'm using a small battery-operated laser in green with 5 mW power and a 532 nanometers wavelength. Positioned in the middle of this interferometer is a laser beam splitter, a small glass plate fixed by 2 aluminum segments. In addition, I have installed 2 mirrors, both equipped with vernier adjustments, as well as a plane lens, which will allow us to view the interference pattern enlarged when transmitted on the opposite position screen, made of plywood. The entire apparatus is mounted on a stable tripod and freely rotatable. A camera is installed over the center of the pivot axle to record the on the plywood screen transmitted interference pattern during the rotation. We are now viewing the plywood screen through the onboard camera. At the beginning of the first experiment, we have to adjust the mirrors by the vernier adjustments to the point that we are able to see a clear and good visible interference pattern on the screen. Like Albert Michelson and Edward Morley over 100 years ago, we are now moving the entire interferometer into a horizontal rotation. Because of the camera, we are now able to nicely view the interference fringes during this rotation. As we can see, there are no shifts in the interference pattern when a complete rotation of the apparatus by 360 degrees occurs. We now conclude the first experiment with the same results as discovered about 100 years ago, and take some time to make a few changes to the interferometer for the upcoming second experiment. Just as in the previous experiment, we are now starting with the vernier adjustments of the interferometer until we are able to see a clear and good visible interference pattern. The only difference between this experiment and the previous one lies in the positioning of the rotating plane. This time, the rotating plane is positioned vertical to the Earth's surface. We are now moving the entire interferometer in a slight vertical rotational movement and are watching the projected interference pattern on the screen. You are now able to clearly see a movement of the interference fringe pattern. If we look closer, we are also able to see that when a complete rotation of the interferometer by 360 degrees occurs, a complete standstill of the pattern movement happens at 2 points. After each interruption of the interference fringe pattern movement occurred, it will proceed and move in the opposite direction. I would like to explain this process on hand a small simulation. We are now able to see the construction of the interferometer at the point where the interruption of the moving fringes occur. The second point, where a stillstand of the fringe movement happens, is positioned at the opposite side of the 180 degrees mark. If we look closer at the construction of the interferometer at those two positions, we will be able to notice the beam splitter is positioned horizontally to the Earth's surface. The two mirrors, typical for Michelson interferometer, are positioned in an approximate angle of 45 degrees to the vertical axle. Between those 2 points, we are now able to see a shift in the interference fringes by 11 to 11.5 peaks. This means that a bright beam of constructive interference is moved during a 180 degrees rotation of the interferometer by 11 to 11.5 complete places to the right or the left, depending on the direction of movement. I also would like to mention that a slight variation in the strength of the fringe pattern movement occurs during different times of day. According to my knowledge, we are looking at a completely new discovery and never before explored phenomenon. I hereby would like to say goodbye and thank you for your time and attention. Sincerely, Martin Grusenig.
So that was a pretty awesome experiment. As soon as I saw that, Martin didn't deduce the downward flowing ether, but as soon as I saw it, I knew what it meant in terms of the idea of the downward flowing ether is that that's the effect of causing the fringe patterns. This paper right here by these scientists at the Armed Forces Technical Research Center in Egypt, they came across his experiment. They've been doing some of their own work, but what the bottom line is that it comes into the discovered phenomenon of the vertical flow of ether into Earth's surface, as well as into any mass, including the fundamental building blocks. And I think this paper was in 2013 or so. And but I basically have had that concept in my book for, I don't know, 11 years now or something. I'm not the first one to come up with the gravitational push idea. I thought I was when I came up with it because I've never heard of such a thing. But that the vertical rotating interferometer experiment is the best evidence that I've ever seen, and I'd like to see more replications of that. Somebody replicated it with a Scotch tape and bubblegum setup, criticizing Martin Grusenig's build, saying that it's a bad build, but he got the same results, and so that, I don't even know what to do with that, but hopefully others will replicate that because it's a pretty simple experiment, and it's the implications of it are pretty profound.